All right. Hey, everybody. Welcome to the Weekly Space Hangout for Friday, February 6th, 2015. And have I got a treat for you this week? As always, we've got Morgan Rehnberg joining us. Hey, Morgan.
Hey, Fraser.
And we've got a special guest, NASA astronaut Ron Garan, who is joining us from not from space, but from his home. Hey, Ron.
Hey, Fraser, how are you doing? Hey, Morgan.
Hey.
Man, this is great. Ron and I were sort of two of the earliest users on Google+. We both were sort of heavily involved in Google+. You, I believe, started Google+ing while you were in orbit, right?
I did, yeah. So I thought, I guess I don't know if they still have it on there, but it used to say bragging rights under your profile, and mine said I started using Google+ in space. So that was a lot of fun to be. It was just another tool to be able to share the experience with people, and so it was a lot of fun.
Yeah, absolutely. So once again, those of you who have never seen this before, the Weekly Space Hangout, we're going to do a rundown of all of the big stories of the week. But before we do that, we're going to take about 20 minutes to talk to Ron, and especially talk about the new book that he's just written and just published. I think it came out like 4 days ago, so it's hot off the presses. So now, if you want to ask some questions either for us about space or to Ron about all of his perspective, you can do that right now. And so the way you can ask us a question is you can use the Q&A app, which is, if you're watching this video, it should say that we're interacting live with the audience, and you can just go ahead and ask a question, and I will pass that along to Ron. You could probably also you can use Twitter if you want, and just use me at @fcain, and then I will pass your question along to Ron if you're watching and you don't know how to use the Q&A app. All right, well, let's get rolling. So Ron, for anyone who isn't as big of a space nerd as maybe me and Morgan, can you give people a bit of a background of sort of your missions and how you got into this?
Sure. I was in the class of 2000, the NASA class of 2000. I flew twice, once on Space Shuttle Discovery in 2008, and on that mission we brought up the Japanese laboratory and installed it on the space station. I did 3 EVAs, 3 spacewalks on that mission. And then in 2011, I launched on a Soyuz spacecraft from Kazakhstan and did a half-year mission. I was part of Expedition 27 and 28, and also did a NEMO mission, NEMO 9, which was the longest NEMO mission. So we spent about 18 days on the bottom of the ocean. So that's my NASA background.
And so I don't know if you've got a copy of the book kicking around. Why don't you hold that up?
Why don't you mention it? I just happen to have one here, so I don't know if you can see that. So I'm very honored to have Nobel Peace Prize winner Muhammad Yunus wrote the foreword for the book, which should be a hint to you that it's not your typical space book. It has some great space stories and great space pictures, and the enhanced ebook that's out has some amazing videos that we put in too, but it's really a book about perspective and looking at our planet just in a little bit different way, and hopefully be able to, because we do that, put our shared future on a much more positive trajectory.
Yeah, so unfortunately I haven't had a chance to read the book yet. They've sent me a copy, but as I mentioned, I'm in Canada, which is almost as far as being in space. So I'm sure it's coming. But from what a lot of my friends have had a chance to review it. What is this sort of, as you said there's some great pictures of space, but this isn't a space pictures book. This is you're trying to get across a sort of a deeper thought as the purpose of this book, right?
Right. It's called Orbital Perspective because that's what the point of the book is. We need to look at our planet from a different perspective. Not only look at our planet from a different perspective, but look at life on our planet from a long-term perspective, from a global perspective. And really the big takeaway of the book is we still have so many problems. We're still facing so many challenges in our world. And the primary reason for that is because of our inability to effectively collaborate on a global scale. So it's a book, it's a call to action, if you will, to set aside our differences, to work together, to really start tackling the problems that face our global community and tackle them in a way that's much more efficient, much more effective by tackling them together.
Right, and I guess one of those things that you get from that orbital perspective is all of the borders of the world disappear, all of the, it's hard to know whether you're looking at Canada, whether you're looking at the States, or whether you're looking at, some other part of Russia. Things blend, and you just see people, and you see landforms, and you see shared resources, lakes, rivers, things that we all have to work with together. So, how did you kind of come to that realization as you were up there?
So normally what you said is true. Normally when you look at the Earth, we see continuous landmasses separated by water. But every once in a while, you do see man-made barriers to collaboration, man-made borders, the orbital perspective was not born out of a single moment, but if I were to pick one pivotal moment where the kind of light bulb came on more than any of the other amazing moments after months in space, was when I took a picture of this illuminated line that was snaking across this large landmass for hundreds and hundreds of miles, and I didn't know what it was, and it turns out what this is the man-made illuminated border between India and Pakistan. Clearly very, very visible from space. And seeing that, really kind of hit me in the gut, and the kind of light bulb came on in that, here you had this man-made barrier to collaboration, clearly visible from space. This scar on the otherwise unbelievably beautiful landscape, really, to me, was a call to action, a call to stress the need for a much deeper level of collaboration to solve the problems facing our planet. And so, I was one of these astronauts that say you can't see any borders from space, and I've proven myself wrong, because actually there's many borders you can see from space if you're looking for them, and sometimes you don't even have to look for them, they jump out at you.
Yeah, we actually just posted a picture on Universe Today just like 2 days ago, where it was a picture of the border between Iran and Iraq during the war, and there was all of these fortifications, and you could see all of the supply lines and where they were shooting at each other from across this open field.
And if the point of the orbital perspective is if you pull back far enough, all of our differences blur into insignificance, and what you're left with is this beautiful paradise. And there's a lot of concrete messages in the book that we can take away from. The book is divided into 3 parts. The first part is looking skyward, the second part is looking earthward, and the third part is looking forward. Each part has 3 chapters. And in the looking skyward, I use the example of collaboration that built the International Space Station, where you have 15 nations, some of which were not always the best of friends, and I focus in on the relationship between Russia and the United States, and how all the challenges we had to overcome, political, cultural, language, the list goes on, and how we overcame that and built arguably the most complicated, complex structure ever built, and what lessons can we apply to solving the problems facing our planet. In looking earthward, I turn that around, and now I'm trying to put a focus on the Earth and looking at the Earth from the perspective of the planet. And if we look at things from a long-term point of view, not quick fixes, not band-aid solutions, and if we look at a big sphere of influence, not just locally, but in fact globally, we see that a lot of the pieces of the puzzle become clear. And then looking forward, that's the call to action. That's here's some things that are working, here's some things that are helping us to overcome the challenges, here's the things that we need to accelerate.
And I'm hoping, or I'm guessing, that as you had a chance to sort of talk to some of your astronaut friends, you could see these sort of shared experiences, shared epiphanies, because you had all spent that time staring out the cupola window, looking back at Earth. But for those of us who haven't had the chance to go to space, may never get the chance to go to space, how do you think we can kind of internalize those sort of lessons?
Well, the other main point of the book is you don't have to be in orbit to have the orbital perspective, and that's why throughout the book I apply so many examples, or I describe and tell so many examples of people who are exhibiting the orbital perspective without ever having gone to space. And I think by the first thing, for those of us who have gone to space or those who haven't gone to space, I think it's the same process. The first thing we need to do to apply the orbital perspective is to realize the framework that we view the world in. All of us have formed frameworks that we filter the world, the events of the world through, and so we need to identify that. I won't go into any more detail because it's spelled out in the book, and it's I don't know if I could do justice in a short amount of time, but to look at these simplified, in some cases simplified frameworks and understand them and try and overcome them, but also to take, like I said, a big picture perspective to look at what the long-term effects of every decision, of every thought, word, and deed will be, and then realize that our sphere of influence is a lot bigger than we think. Our backyard is a lot bigger than we think. We've had not in my backyard syndrome, right? Back from the environmentalists, but what a lot of people don't realize is that their backyard's a lot bigger than they think. So I think those are some of the principles that, whether or not you've been in space, I think apply to this mindset that hopefully will lead to some big problem solving.
It's funny. It feels like you flipped over the classic question that we always get, we space nerds get, which is how can we afford to travel to space? Why should we be spending the hundreds of millions, billions of dollars to travel to space when there are so many problems here on the ground? But for your perspective, it's almost like we need it, like almost spiritually, to head to space and really appreciate and help new ways of thinking about the problems on the ground. So how do you answer that question?
There are so many facets to that question. There's obviously the technology transfer. There's all the benefits that come from the space program. We've heard that. We've heard of the spin-offs. We've heard about, now we have real tangible benefits that are not just spin-offs. But I think maybe one of the overlooked things is just working together as a global community. If we find things that we can agree on, not all nations are going to agree on all things, right? So there's a lot of countries that don't agree on different policies, on different things that are going on within their own countries and things that they're doing to other countries. And so if we can find those things that we agree on, like space exploration, and start working together on those things, what happens is personal relationships develop, trust starts to develop, we start to know each other. Hopefully misconceptions can be overturned. Hopefully demonizations of whole populations of people can be overturned. And then we can use that as a platform to start working on the things that we don't agree on. But what we tend to do is the exact opposite. We tend to take the things that we agree on and use them as leverage, use them as a stick to force the things that we don't agree on. And that just absolutely does not work. And so, that's why we should, that's one of the benefits of the space program that's often overlooked, is that what it allows us to do is to start working together, and by working together on the easy things, then we can start to work together on the hard things. But there's many more facets to that question too. So,
how do you reconcile the idea of holding up the International Space Station and other examples of cooperation in space with the fact that we are still excluding some nations, some smaller, some quite notable, from participation in our space activities?
Yeah, I don't think we should. I think that's a mistake. I think that is exactly what I just said. It's using the things that we agree on. People want to work with us. That means they agree with what we're doing. They want to work with it. I think one of the countries you're referring to is China. China is going to do big things in space, whether or not we do it with them. And we'll be able to see what they're doing, but we won't be able to see why they're doing it. We won't be able to understand why they're doing it unless we're doing it with them. And so China is a good example of a nation that we have lots of disagreement with. But a lot of those disagreements and a lot of those things that critics voice as reasons why we shouldn't work with the Chinese are the same things they said about the Russians. And so, I think that we should have the Chinese in the space station program. We should be doing joint missions with the Chinese for the same reasons I just stated, that it starts to open up a dialogue, it starts to open up a foundation of relationships where we could hopefully build upon those things and then start to address the things that we don't agree on.
So I got a couple of questions from the audience here. If you got some time, let's see. So Leonard Lindstrom wants to ask, which was a smoother ride, the space shuttle or the Soyuz?
It depends if you mean on the way up or the way down.
I'd love to hear both.
Well, I tell you, the Soyuz. I'm sure you guys have seen the movie Rocket Man. Have you seen the movie Rocket Man? It's like this crazy Disney movie about this guy that flies to space. But anyway, he launches into space and he's just just beside himself. It was so much fun launching into space. Launching on a Soyuz, what surprised me about launching on the Soyuz was how much fun it was. I didn't anticipate it to be that much fun, and the difference between a shuttle launch and a Soyuz launch is, in the shuttle you're riding in this big massive vehicle, and of course there's a lot of shaking and a lot of vibrations and G-forces and everything else, and you have the same thing on the Soyuz, but the difference is the Soyuz, you kind of feel like you're wearing the rocket, like you have the rocket strapped to your back, and it was a lot of fun. On the way back, the shuttle is a lot more benign than the Soyuz. The Soyuz was a wild ride. I heard Scott Kelly describe it as going over Niagara Falls on a barrel that's on fire, followed by a car crash. That was a really, really violent ride. I remember at one point during the reentry, Andrei Boroshenko, who's sitting in the left seat, I was in the right seat, yells out in Russian, "It's just like an American amusement park ride." But it was a lot worse than any ride that I've ever been on. So.
Wow. And you're a fighter pilot, right? So I guess the launch feels more like a jet, and the landing on the space shuttle feels more like what you were accustomed to.
Yeah, the interesting thing on the launch from a former fighter pilot perspective is you experience acceleration in fighters quite a bit. But what was interesting is after 5 or 6 minutes of this massive acceleration, you really get the sense that, wow, we must be going unbelievably fast right now. And this is not anything that I've ever experienced before, this level of acceleration for this long. So.
Yeah, I originally, for all the astronauts that I have interviewed, I used to ask that question, like, what did it feel like? Was it exhilarating? And I got the same answer, which was mostly no. Mostly, you're very well aware that you're in a bomb, and you're aware of the disasters that have already happened, and it's very hard to kind of get at peace with it until you reach the point where the shaking stops and the sort of smooth vacuum of space starts to take over.
Yeah, I mean, the other difference between the shuttle launch and the Soyuz launch for me personally was the shuttle launch was my first launch. I was the flight engineer, if you will. I was MS2 on it, so I had responsibilities that I had to do. I had things I had to, really keep track of, and everybody was counting on me to keep track of. The Soyuz was my second mission, so I knew a little bit what to expect, and I was sitting in the right seat, and I had very little responsibilities. They didn't need me even in the seat. They could have flown with baggage there, and they would have been just fine. And so, from that point of view, I was a lot more, I guess, relaxed is maybe the right word, but it was a much more enjoyable experience for me on the Soyuz. I would describe my shuttle launch the way you described it before, but the Soyuz one was, you're obviously aware of the danger, but what you're anxious about is not the danger. You're anxious about screwing something up in face of the danger, like making a mistake. So there was pretty much nothing I could do to blow us up in the Soyuz. So there was a lot of mistakes I could make in the shuttle that wouldn't be good. So.
Right. So I got a question from Nancy Graziano, which was, did you always aspire to be an astronaut, or was it a career path that just presented itself to you along the way?
No, I didn't always want to be an astronaut. I wanted to be an astronaut only since July 20th, 1969. So that was, me as well as millions of people around the world. That was the day we watched the first moon landing. I'm old enough to have that as one of my most vivid childhood memories. And so, I mean, the real answer to the question is yes. I worked my whole life since a small boy to fulfill that dream. So it's what I've always wanted to do. And there was lots of twists and turns along the way, and I really enjoyed my career as a fighter pilot. And glad that I had the opportunity to do that, and glad that I got the opportunity to fly in space too.
And was that the common thread? I mean, that of all the people who you talked to, that inspiration from the Apollo landing for the later classes, the class 2000, etc., that it was the Apollo missions, and that they had been, I guess, grooming themselves their whole lives for this opportunity?
I think it's a common thread. I don't think it's not a universal thread. There's many people that never thought of becoming an astronaut until right before they applied. So there's it's. But I would say, I don't know what the statistics are, but I would say a significant percentage of the people were inspired by the space program to become astronauts at an early age.
So Ben Gaisley asks, would you sign up for a one-way mission to Mars? And do you think it's going to happen?
I would not sign up for a one-way mission to Mars. I'm already living on my favorite planet, do I think it's going to happen? I don't know. I think we shouldn't fly people to a planet that we have nowhere to get them back. That just doesn't make much sense to me. If you put a high value on human life, then we should be able to ensure that people who do this type of exploration have a reasonable chance of well, I shouldn't say surviving, because hopefully they do have a reasonable chance of surviving, or they wouldn't go. But I think a better way to do it would be to have at least the capability for a round trip, or at least the capability to follow them with emergency supplies, or do something along those lines.
So you'd visit?
Oh, I'd love to visit Mars. Yeah. That'd be cool.
Awesome. Okay, so we've got just a couple more minutes left, and I wanted to give you a chance to let people know about more about how they can find the book, the different ways they can get it, and then just ways that they can get involved in the mission that you've set out for all of us.
Yeah, the mission of the book is to spread this message. It's a message of hope. It's a message of the need for a deeper level of collaboration to solve the problems facing our planet. And so really it's a call to action. And I hope that everybody listening could help us spread that message and help us spread this need to not accept the status quo on our planet. So the other main theme of the book is that nothing's impossible. So we have a lot of doom and gloom around us right now. There's almost a billion people who don't have access to clean water. There's so much poverty. There's conflict. There's terrorism. There's all these really negative things happening in the world. But really, that doesn't define us. What defines us is the compassion, the ingenuity, the creativity that defines the human species, and all of that wonderful stuff gets really drowned out under the enormity of all this negativity that's around us. So it is possible to lift the entire population of the Earth out of poverty. It is possible to do that. And so one of the other points of the book is the first step to affect real change is to believe that real change is possible, and to have an attitude that if we can go to the moon and back, if 15 nations can join together and build the most complicated, complex structure ever built in space, imagine what we can do by working together to solve the problems facing our planet. And so we ask that you help us to share that message. We have a website at orbitalperspective.com, and that's one way to get the word out. But we're on Twitter, we're on Facebook, and just if you do read the book and the message resonates with you, then I would say share the book, share the message with as many people as you can. If you can help us by writing reviews about it, what really touched you, what really you thought was important part of the message. I think the more people that are able to do that, the more the message will be able to spread, and the more good it will be able to do.
That's great, and we'll put links to all of that in the show notes and stuff, so people can click. But it's orbitalperspective.com, and of course, if people want to follow you, Astro_Ron, and of course on Google Plus, followed by more than 3 million people. So there's lots of ways that you can interact with Ron and interact with the book and sort of share the word. So Ron, absolute pleasure. Thank you so much for joining us on the
same here, Fraser.
We really appreciate it. I'm so glad we got a chance to finally meet in person.
It's awesome.
All right, we'll see you later. Thanks a lot.
All the best. Take care.
Take care.
All right, Morgan. So it's just the two of us now. So we've got a bunch of space stories to get through in the time that we have remaining.
That's right.
Awesome. That was cool.
Oh man, can talk to an astronaut off my bucket list.
Yeah, done. Okay, so let's talk about a couple of stories that we've got here. We're going to talk about the NASA budget. I wish we had Why don't we have Casey Dreyer on to talk about the NASA budget?
Yeah, I put it up there just sort of assuming that he would swoop in and take it from me.
Yeah, because there's so much doom and gloom, and now things are coming up so rosy.
Yeah, it's a good message.
And he was a big part of it, so it's funny. Anyway, so we're going to talk about that. We're going to talk about FAA regulations of the moon. We're going to talk about Rosetta. We'll talk about New Horizons, some SpaceX stuff, and some Martian meteorites. So let's start with the budget.
Yeah. So this week, President Obama released his proposed budget for 2016 for the United States. And included in that, of course, was the budget for NASA. And it's important to note right off the front that this is only the very first step in a process that can go on forever. And what we see today doesn't reflect exactly what we'll see if we have a budget sometime in the coming 3 or 4 months. But it kind of gives a sense of where the president and the NASA administrators see the space agency going. And it's the starting place that Congress will then use to sort of tweak here and there based on the categories of funding that the president has laid out. From a top-level perspective, this is a good budget. It's $18.5 billion for the space agency, which is about $500 million more than they're currently funded at this year. But the bigger news here is that this is a really good budget coming from President Obama. It's about $1 billion more than he proposed last year. He proposed about $17.5 billion. Congress came in and bumped that up by another $500 million to $18 billion. But this year he's out in front, proposing the first increase in the NASA budget from him in more than 4 years.
When does that ever happen, where Obama asks for the budget for something and Congress says, no, you're probably going to need more? And then he comes back and goes, no, you know what, I want even more. And they go, yeah, that's fine, that's good.
Yeah, it's a real strange situation that space finds itself in. It crosses the typical party lines, and we've seen both Democrats and Republicans come out saying, well, this budget's a good start, but we're going to do better. And there's certainly things that Mr. Obama has proposed that we will expect Congress to kind of tamp down, and things that they're certainly going to beef up more. This budget includes about $5.3 billion for science. That includes basically all of the missions, paying the scientists that run those missions, and that number is about flat over last year. The president's proposed more money for the Commercial Crew Program, so that's SpaceX and Boeing, and less money for the Space Launch System and the Orion capsule. Those will almost certainly be switched by Congress. Congress is much more in favor of the Space Launch System than they are of the Commercial Crew Program. But the big news, I think, here is what did get funded for the first time and what hasn't been funded. And the headliner here is the mission to Europa. The president's budget for the first time includes money to prepare a mission to go to Jupiter's moon Europa. It's a small amount of money, about $30 million, which is only about a third of what Congress appropriated last year. But it's important that it's in the president's budget because only NASA and the president can decide to start a program. The Congress can appropriate money to it as much as they want, but it's up to NASA and the president to decide, yes, this is the direction we're going to go. And so the fact that it's in there, even at a small number like 30 million, is a really important step, and it means that they're now going to start prepping this mission probably for launch in about a decade. And then, of course, it will take several more years, maybe up to 6 years after that, for the mission to actually arrive at Europa. So we're talking.
Is it orbiter, lander? What's it probably going to be?
So the most likely is going to be kind of a hybrid. They call it the Clipper because it's going to go into orbit around Jupiter, but not into orbit around Europa. Because of the unique orbital configuration of Jupiter's 4 big moons, Io, Europa, Callisto, and Ganymede, it's actually really difficult to get in orbit around any of them other than Ganymede. And so instead they'll go into orbit around Jupiter and then make a series of close flybys of Europa to do the science that they want to do. They also include money in the budget for increased development of the next Mars rover, which is currently called Mars 2020 after the proposed launch date. And the idea here is this is probably going to be a rover that's pretty similar to the design we saw for Curiosity, with the addition of perhaps being designed to collect and sort of bag samples and then pile them up for a possible future sample return mission. So the rover would find interesting samples, it would seal them up in sample containers, and it would place them in a location where a future lander could come by and pick them up.
Or astronauts.
Or astronauts in even the farther future from that.
Yeah.
A couple of losers in this budget are the Lunar Reconnaissance Orbiter and the Opportunity Rover, both of which received zero funding under this proposed budget. Now, NASA has since clarified that they intend to at least try to find money in the existing budget to fund Opportunity through 2016. And both of these things were actually eliminated in last year's budget as well, and Congress came back and appropriated additional funds for them. So I wouldn't say that it's time to worry about LRO or Opportunity yet, but it's clear that both of those have reached the point where it's a yearly effort now to think about, is it worth expending what amounts to about $25 million to fund these guys?
Yes.
And so far, Congress seems to think the answer is yes. And the scientists operating these missions agree both of these missions were recommended highly for renewal during the senior mission review panel that happened last summer. Also in this budget request is money for the National Science Foundation. This is separate from NASA at $7.7 billion, which is a 5% increase over the 2015 budget. And this includes money for things like ground-based telescopes, but also includes funding for basically all other non-medical branches of science research here in the United States. The President has put a lot of money in this part of the budget towards researching climate change, and so it's likely that this will see a substantial revision by Congress in the coming months, probably much more substantial than what we saw from NASA.
Yeah. All right. Well, this is great news. I think, as I said, so surreal to have this very space enthusiastic team of politicians working together to help make our dreams come true. So I'm stoked to see how this, and I hope, I don't know, maybe there'll be a few more revisions where they just keep going back and forth, piling on an extra $500 million here and a $500 million there, and maybe they'll build the terrestrial planet finder. That would be great.
Yeah, we'll keep our fingers crossed.
All right, well, let's move on. So the next story that we've got this week is let's talk about regulations of the moon. So, am I allowed to sell property on the moon? Am I allowed to mine the moon? Can I own the moon?
The answer is no, maybe, and no. And this is a problem that's sort of finally becoming a real thing for the first time. So way back in 1967, the United States, the Soviet Union, and a whole bunch of other countries signed a treaty known as the Outer Space Treaty. And this treaty basically said that you can't own a celestial object and you can't own a piece of a celestial object. It was modeled after the treaty that governs Antarctica, one that continues to remain in effect successfully to this day. No country can lay claim to a piece of Antarctica for any specific reason. And, you know, so America then went and landed on the moon 6 times, but other than that, we haven't really done a lot with physical presences on celestial bodies. But we're finally kind of at the point where commercial entities are getting ready to consider landing on the moon themselves. We have the Google Lunar Xprize, which is a competition between a number of universities to put the first private or the first non-governmental lander or rover on the surface of the moon. And of course, we see companies like SpaceX developing private launch capabilities. And so people are thinking, well, hey, maybe there's things on the moon that we'd like to mine and bring them back. But in order to invest the tremendous amount of money necessary to do this, these companies want some sort of assurance that when they find something valuable and start mining it, another company can't just land right next to them and start aping all of their work. But how do you do this when you can't claim private or even public ownership of parts of the moon? So the FAA has been thinking about this in response to requests from a company called Bigelow Aerospace, which is thinking about trying a private landing on the moon. And the sort of solution that they're proposing is to regulate not who owns what on the surface of the moon, but who can launch to places on the moon. Because here in the United States, the FAA, which is the Federal Aviation Administration, controls all, basically, space launches. If you want to launch to space, or even, in fact, travel above a certain altitude above the continental United States, you need approval from the FAA. And they're basically saying they won't approve launches by companies who intend to go to the same place that another company has already sort of staked a claim to. And so there's no legal claim on the surface of the moon, but the FAA says, well, if they're there, we're not going to let you lift off if you intend to go to the same place.
Right, but you can control whether or not people can lift off. But once they're in space and they decide to just change their flight trajectory, or maybe they never were going to follow that flight trajectory anyway. But I guess the whole point is that you can affect their operations back on Earth. You can fine them. You can send their executives to jail.
Well, you can,
as long as
if
people
those
are still
companies are also American companies, and this is the rub. The FAA, of course, has no jurisdiction over other nationalities, and so, if an American company lands and finds, a giant platinum deposit on the moon and decides to start mining it, the FAA can keep other American companies and other companies launching with American companies from going there, but they can't stop, say, a Chinese company or a Russian company or a German company from launching and going there because they don't have any jurisdiction there.
Yeah.
And so it's a stopgap measure, and it really kind of highlights the fact that what worked in 1967 when nations could agree to these rules is going to need to be revised if we want to enable commercial or even non-commercial private exploration of the moon and other celestial bodies. And we're just kind of seeing the first steps of that now.
Yeah, and this is the, possession is 9/10 of the rule, right? Like if you get out there and you can land on an asteroid and you start mining it and people have a problem with that, come on up to the asteroid and stop me. So I think that's
absolutely.
And unfortunately there are some pretty big issues when you think about it. I mean, obviously, if you affect the trajectory of an asteroid to move it into an orbit that's maybe more advantageous for you to be able to mine it, but that could be dangerous. Sending a mining operation to Mars and potentially contaminating the environment of Mars with your Earth-based bacterium, or going to Europa or going to Enceladus, any of these worlds, and which are right now completely pristine, and contaminating them with us. And so it's a tough thing, and I agree that I don't think the FAA solution isn't the right one. In the past, our solution to this problem was we killed each other. Right? This was war. Was the
Ron
way you
wouldn't approve of that. Said Ron would not approve of that.
No, exactly. Right? That this is so now can we, as a more enlightened species, now that we've seen our history, now that we're seeing an entirely new environment out there, which is, to the best of our understanding, devoid of people already living there. How do we move outward without it turning into war? So good start, FAA, and I wonder sort of where this will eventually lead us.
Indeed.
Yeah, I won't rule out war, unfortunately. All right, let's move on. So let's talk about Rosetta, Rosetta's about to snuggle a lot closer to 67P.
Yeah, that's right. So over the last few months, in fact, really ever since the Philae landing back last year, Rosetta's been orbiting the comet 67P at a distance of about 26 kilometers. And this is what's called a bound orbit, which means that basically it's stuck in orbit around the comet as the comet goes around the sun. But what they want to do now is get really close. They want to get as close as 6 kilometers from the surface. And in fact, they're going to pass right near some of the most active regions of the comet. And this will allow them to get both high-resolution images, but also make detailed measurements of what the space environment is like right near the surface of this comet. And that's going to happen a week from tomorrow, next Saturday. And in preparation for that, Rosetta's actually moving away from the comet right now. It's going to move away out to about 140 kilometers, so it can take kind of this sharp trajectory in and do like one quick pass, basically, without having to linger in this environment close to the comet. And so starting earlier this week, it began increasing its orbit from 26 kilometers to 140, and then next Saturday, on Valentine's Day here in America, that will zip in to just 6 kilometers away, make the sort of the highest resolution measurements we have yet, and then pop back out to safety. And then as the year wears on, they're going to sort of make observations at different distances. So they've got the close-in 6. They've got this 26-kilometer orbit. They're going to do things at 30, 40, 50 kilometers, so they can understand, well, how does the space environment around the comet change as you move away from the comet? And that also will take into account the fact that the comet's getting closer to the sun. It's going to start to sort of puff up, release more material, and Rosetta will be sort of right in the thick of the action when it has its close approach to the sun.
Got a question here from Mark Brown. What is the projected lifespan of Rosetta?
So it's expected to last through 2015 without any difficulties. And then it's really more of a financial question after that, because after Rosetta makes its closest approach to the sun later this year, it'll start moving back out towards the outer part of its orbit, and it's going to become a lot less active, and it's going to die down. And then kind of the question remains, is there enough interesting things to look at when the comet isn't active to justify maintaining what's a pretty expensive mission? And so, to my understanding, ESA has only sort of committed to following the comet through 2015, but that's not a technical limitation. That's more of a budgetary one.
So Hugo Burnham has challenged us to say the name of 67P. Have you?
Churi Yumanov Gerashmenko.
There you go. Done. Take that. Okay, let's move on. So this is the part of the show where we talk about the ideas suggested by the Weekly Space Hangout crew, and this is of course a community on Google Plus that talks about the show that we do, as well as just space in general, and it's a fantastic community. Highly recommend it. Do a search for WSH Crew on Google Plus, and you'll get to the community, and there's hundreds and must be about 300 people there now, and just really tight knit. They love space. And they're the best. So
new faces in our rundown this week.
Yeah, absolutely. This is great. So if you've never watched the Weekly Space Hangout and you're watching it now, and the suggestions of guests comes from the Weekly Space Hangout crew, I'm just saying. So we definitely really appreciate the dedication from the fans there. And as part of this, we let them also suggest a few stories. So I'm going to pull one here. This comes from Matt Woods, and this is that the Moroccan Meteorite may be 4.4 billion-year-old chunk of the Martian crust. So this is in your wheelhouse, planetary geologist Morgan Rehnberg.
Yeah, and so this is a meteorite that was picked up in Morocco. It's an area where we've actually found a substantial amount of meteorites. In fact, if so meteorites are named by one of two ways. If they fall in a place that sort of has a very kind of built-up government, then they're named by the closest post office that they land at. If they land, however, somewhere that doesn't have, a comprehensive mail system, then they're given sort of a geographic name. And so this one was named NWA and then a series of numbers, and that stands for Northwest Africa. Northwest Africa is one of sort of the prime places to find these meteorites, excuse me. And this particular piece has now been studied, and it determined that it came from the crust of Mars. In fact, it came as a piece of the crust that originally formed about 4.4 billion years ago. And this is needless to say, really old. But it's really old even in the lifetime of the planet, because we typically think of the planets as having formed by about 4.5 billion years ago. And so this would be evidence of what Mars looked like very early on in its history. A history that in many places on Mars has been lost since then, because every time an asteroid or a comet hits Mars, it leaves a huge crater, it distributes that material across the surface, it messes up sort of our historical record. And so by studying this, we'll be able to get a sense of what the Martian surface was comprised of way back when it was first forming. This rock is probably older than any rock that we have, any sample we have of the Earth, and is similar in age to samples that we found, for example, that the Apollo astronauts have picked up from the surface of the Moon. And some early analyses suggest that it seems that just like today, back then the Mars surface was kind of an amalgam of lots of stuff from different impacts. The early solar system was a very violent place. In fact, at 4.4 billion years, Mars would have been being pelted probably pretty continuously with the leftover chunks of planet-forming bodies called planetesimals that never really got incorporated into a planet. And what we think of as sort of the heaviest period of bombardment here on the Earth would still be about 700 million years later. And so this is really, really early piece of Mars, and it offers us a glimpse at the planet that we don't see when we look at it, even from something like Curiosity or Opportunity.
Yeah, so just, I mean, you mentioned just sort of offhand that Africa is sort of a great place to find meteorites. That's just because it doesn't experience a lot of the kind of weathering and vegetation that we might get, say, here in the Pacific Northwest, right? And so you can see sort of funny-looking rocks just sitting on the ground and identify them, sitting in the sand. It's the same thing as Antarctica, right? You go down to Antarctica, you find rocks sitting on top of the ice. They had to come from space.
Yeah, Antarctica and North Africa are sort of the two prime locations if you just want to walk out and pick up a meteorite. And in fact, expeditions go out pretty frequently to Antarctica to look for new falls because they're occurring. The Earth is being struck by meteorites all the time. Every time you see a shooting star, you're seeing a meteorite, and some pieces of those make it to the surface. And normally, they fall on the street and they look like a piece of road trash. But they fall in Antarctica and they stick out very well against the white ice of the glaciers.
You don't realize that you're being surrounded by meteorites all the time. That but we can't recognize them because they're rocks, or they like if they're metal, then they just sort of dissolve and they get rusted in the rain and they just disappear over time. So it's you got to go to one of these places where you won't sort of expect to find a rock that's just sitting out there, and that gives you a chance to identify it for what it is. Okay, so I got a great picture here, and I know we've done this picture a bunch of times, so I'm just going to do this one more time. And this is a new picture of Ceres. Oh, okay, hold on. It's gonna. Why is this? No, I don't want Internet Explorer to be my default browser ever. Okay, let's see if I can pull this up. There you go. So you see this? This is the new picture of Ceres.
Yeah, almost every day we're getting a better picture of Ceres, and we're really starting to see the craters on the surface, which isn't surprising that we'd see that, but to really get a chance now to look at it is exciting. And every day it's going to be sharper and better, and I can't wait until dawn arrives. I think it's in March, and begins finally to get a close-up look at one of the largest unstudied bodies in the solar system.
And one of the big mysteries from me, and so if you watch this video, hopefully you can see there's the white spot which we've been talking about, but there actually appear to be a few of them now. So whatever is that white spot that you're seeing, the brightest one, there's now that same phenomenon is happening a bunch of places on the surface of the object. So So I think it's and still every time we talk to astronomers, they don't really know what it is. Right now, let's make some predictions. Place your bets. What are the white spots on Ceres?
I would have to guess that it would be some sort of ice. Hubble made the discovery, I think it was last year, that there seemed to be vapor plumes coming off the surface of Ceres, like we see, say, off the surface of Enceladus. And so the idea that some of that might be condensing back onto the surface, or vice versa, that something happened that revealed one of these ice places, and it's now sort of sublimating off into space, would be sort of an initial guess.
All right.
But the good thing is we'll know really soon.
Yeah, no, for sure. And my guess is a crater with ice in it, and it's sort of acting a bit like a lens. It's sort of focusing the sunlight that we're seeing to make it a little brighter because of the shape of the crater. So we'll see what happens. I'm really excited though. And then another cool picture. Let me see if I can find this one, which is that now we've got our first picture of Pluto and Charon from New Horizons.
Yeah,
our
so
next picture.
Just like with Dawn and Ceres, almost every day now we're going to be getting better and better pictures of Pluto and Charon, etc. Now we have a few more months to wait before the pictures we're getting are better than we've ever gotten before. And so New Horizons makes its closest approach to Pluto on Bastille Day of this year, which I think is July 15th. And starting about 2 months in advance, in early May, we'll start to get pictures back from New Horizons that are better than what Hubble has been able to return from Earth orbit. But every day then between the early part of May and the closest approach on July 15th, we're going to just see more and more detail, just like we are on Ceres. And it's really kind of, I think, starting to hit home that we're almost there. It's been a 9-year journey, and in just the span of a few months here, we're going to get our first close-up look at two large bodies in the solar system that really never have been understood before, and that makes 2015 a really exciting year.
Yeah, well, I mean, when you think about it, we posted a story on this last week about how the solar system's yearbook is going to get finally filled in, right? All of the large bodies in the solar system will have been filled in. There's still, we haven't seen close pictures of Haumea and Eris and Sedna and things like that, but for a lot of the big objects that we're concerned about, we will now have close-up pictures of all of them, all the moons, all the big asteroids. It's kind of stunning when you think about it.
Yeah, it's really exciting.
Yeah. Cool. All right. Well, so one last thing, because this is supposed to be the Elon Musk, This Week in Musk, and so we've got one quick announcement, which is February 9th. There's going to be the launch of the Discover mission, right?
Right. So this week they performed what's called the static pad test fire, where they basically light the rocket, make sure it works prior to rolling it out on the launch pad. So they'll be launching the Discover mission. Think Discover with no E. NASA's getting in on this Web 2.0 naming scheme. And it's going to be launching it on the 9th. And it's going to put it at the L1 Lagrange point. And what a Lagrange point is a place basically where the gravitational force of the Earth exactly balances the gravitational force of the Sun. And it's a really cozy place to be because once you're there, there's really no net tug on you, and you can sit there pretty much in peace. And Discover is going to go there, and it's going to take pictures and make measurements about the energy emanating from the surface of the Sun. And after launch, the Falcon 9 is going to attempt once again to perform a landing on one of these barges out in the Atlantic Ocean. And we saw a couple weeks ago how close they were how seemingly close they were to succeeding at this, and they've corrected the issue that stymied them last time. And the hope is this time they'll be able to perform a nice clean landing right on target.
Yeah, much more hydraulic fuel. And what I think is really cool is they've named the barges after spaceships from Ian M. Banks' books. So I don't know if you've heard that. I forget the actual names, but
I don't remember the name either. Yeah.
Love You Forever, I think, and there's one other. Yeah. So I'll dig up the names. I'm sure the people
Somebody
watching
will
we'll post the names. I'll look that up. Why don't you? We should wrap this up. So wow. Astronaut here on the Weekly Space Hangout. That was amazing. And actually, a lot of folks in the Weekly Space Hangout crew suggested Ron and other astronauts. So we are your vessel. Weekly Space Hangout
keep suggesting.
You tell us who you want to talk to. The key, right, was Ron just wrote a book, and he wanted to let the world know about the book that he had just done. So it was a great opportunity, a really great connection for us to be able to have him here on the show. So
do we have a guest next week?
Do we have a guest next week? We've got a bunch of guests lined up. I'm not sure who the guest is next week. Maybe Paul Glister from Centauri Dreams is coming. So I'm not sure whether it's next week. We've got a bunch of great guests. So big props to Susie Murph, who's our producer, our producer on the Guide to Space videos, but also is a producer for the Weekly Space Hangout, and she has been organizing a bunch of guests. So you told us that you want to see some guests, and we're going to do what we can to try and bring some fresh faces, because now, don't get me wrong, I mean, Morgan and Brian Koberline and Dave Dickinson and everybody are just wonderful to have, but there's a lot of space journalists out there who have got some great perspectives, and I would love to have on the show and have them join us. So come on, space journalists, we're ready to hang out with you. Morgan, where do people find out more?
Yeah, well, right after this, if you'd like to ask me my deepest feelings about meeting an astronaut, or any other questions that we might have missed this week, you can head over to the Google Plus Space community. Just go to plus.google.com, choose Communities, and click on Space. I'll be answering questions there for an hour or two this afternoon. Of course, I encourage you to follow me on Twitter at Morgan Rehnberg. I'm trying to tweet more excitingly from Twitter as well, and you can find my website at cosmicchatter.org.
Yeah, if you're not already following Morgan on Twitter and on Google+, what is wrong with you? All right, so the names of those spacecraft, some names of the drones are Just Read the Instructions, and Of Course I Still Love You, which is great, and that's from Ian M. Banks. I think it's just the Culture series. They come from the Player of Games. So, cool. Well, hey, thanks everyone for watching. Thanks Morgan for joining us. Thanks Ron, especially for joining us. It was an absolute pleasure and a treat to have an astronaut here on the Weekly Space Hangout. I am, of course, F. Cain on the Twitter. You can also follow me on Google+. Highly recommend you subscribe to us on YouTube if that's where you're watching this, so that you can see the other videos that we do. We do the Weekly Space Hangout every Friday here on Google Plus at 12 Pacific. The next thing we're going to be doing is we're going to be doing Astronomy Cast on Monday, and we've got a pretty cool. We're going to be wrapping up our series on finding planets. We're going to be talking about actually studying planetary atmospheres, coronagraphs, things like that. And then we're going to go into, I think, a pretty cool new series, which I'm pretty excited about. So we'll talk about that next week. All right, well, thanks, everyone. We'll see you all next week.